diving deeper with parts of an expression. So we're going to investigate expressions and variables with them. So today's goals are: I can identify parts of an expression. So go ahead and pause here to get that down, and you're ready to move on. Let's think about ways of interpreting when we go to solve, okay? So Derek needed 147 gallons of water to fill up his family's new hot tub. The tub holds 250 gallons of water. How many gallons are needed to fill the tub? So let's think about two equations we could write for this. So we know that he needs 147 gallons to fill up the tub. The tub holds 250. We want to know how many are needed to fill the tub. Well, if we know we need 147, we need to add however many gallons to make 250. So this is one way we can write it to figure it out. And then the other way, which would be the way we probably would use to solve it, is if we take that 250, subtract the 147, and that would give us our x. And so we could just take that amount and subtract out the other and figure out exactly how much it would be, right? And then we can always check it by adding 4, 10. So that gives us 3, a 0, and a 1. So there are 103 gallons needed, and if we added that here, we should end up with that same value. But we can make both of these expressions end up showing the same thing in the end, because in either case, that x is going to have the same solution, whether we subtract out and we find that, or we go with the other piece and think about what's the missing number that goes with this, okay? So we can do the same thing on anything. We're going to talk about some more parts of the coefficient, or parts of an expression here in a moment. So we want to figure out what are the variables and what are the coefficients in this one. Okay, so remember that coefficients and variables. So variables are all the letters in any equation. So C for that one, W for that one, Q for that one, K here, and the N. Okay? And the other question is, what's the coefficient? Well, coefficient, remember, is the number that you multiply by the variable. So 4 here, 8 here, 7 here. This one doesn't have anything, but what's the coefficient of anything? It's just like if I said I wanted you to make k into a fraction, you just put a 1 underneath it, right? Well, same thing here. There's also a 1 here that would be the coefficient. Same thing with this one. In the same spot we would have right here, we would just have a 1. And we don't have to write it because we don't need that extra work there, but that also works. So coefficients, variables are some parts of equations, but there are some other things that we need to talk about as well. So jot these down. Next thing we have is term. So a term can be a signed number, a variable, or a constant multiplied by a variable or variables. So in here, the terms are any of basically the chunks. So like in the expression 6z plus 15r plus 23 minus 6a, 6z is one of the terms, 15r is a term, 23 is a term, and 6a is a term, because those are all separate parts. Constant is a value that does not change. And so those are just our regular numbers. They don't have any variables with them. So like 9 is the constant here. So Coefficients we talked about before, those are the things that we multiply the variables by. Constants are numbers that do not change, so they're any actual number. Terms are the chunks of what we've got, so 2x, the 4y, and the 9. And then when we have like terms, we can put like terms together. We can put things together that are the same. So in 4x plus 13 minus 2x plus 6, 13 and the 6 are both constants. We can put those together. The 4x and the 2x both have x, so I can take 4x and subtract out the 2x from it. So I can make the 4x minus the 2x into just 2x, and the 13 minus 6. As long as that x is part of it, we can just straight up subtract those, because it doesn't matter what those numbers are. That variable will change that answer anyway. So take a look at these and find the like terms. So the first one, like terms, are 7t and 2t. Second one, the like terms are 13 and 12. They're both constants. Next one is the 6 and this 5, because those are both constants. And the last one, 8h and the 3h. So like terms are just finding those things together. So like for this, we could have made that into 9t and then subtract the rest of it. We would add 25 here. 6 minus 5 gives us 1. 8h plus 3h gives us 11h. Since those are both added in, we can just use them like that. Okay? All right, let's move on. Words, words, words. So we're going to do some words to help us figure out these other ones. Okay, so just like keywords and problems, you can read equations and figure out the same sorts of things, right? So here we go with this first one, the sum of a number and 5 gives us n plus 5, right? Because it's the sum of those two things together. Here we have m minus 7. So what would be that words that we would use there? So yeah, it would be the difference of a number and 7. Here we have a 6 and an x, or 6x. So that would be product of 6 and a number. So if this says quotient of a number and 9, yeah, it's going to be division. So we end up with y divided by 9, because it says the quotient of a number and 9. So that and part just tells you which way to put it in order. Same thing happens with multiplication as well. If I say 5 times the sum of a number and 9, we have to find that sum first, and because it says 5 times the sum, we have to put that in parentheses, because otherwise it wouldn't get the addition wouldn't get done until afterwards. That's why it's different than the one right below it. It says 9 more than 5 times a number. So that would be 5 times a number, and then 9 more would be adding to it. So if this says 6 less than the quotient of 49 and 7, what do we need? Well, it says the quotient of 49 and 7, so we need 49. And since it says quotient, we're dividing the 49 and the 7. And then we need 6 less. Now, because it's order of operations, would I need parentheses? No, because division comes before subtraction anyway, so I could leave it alone. If I wanted to, I could put the parentheses. It won't matter. It's going to get the same either way. Okay. All right, so we are done with that. I can identify parts of an expression, make sure that you've got those terms. Our big things that we had with this is how are constants and variables different from each other. So constants are those things that don't change, And variables can change. So constants are just numbers. Variables are letters that represent a number that could go in there. What about like terms? What are those? Yeah, those are things that have the same parts to them. Hang on a second. Sorry about that. So if I have 4x minus 3 plus 2x, the 4x and the 2x are like terms because they have the same variable. So I can, and what can I do with those? Well, if they have like terms, I can put them together. Since this says 4x and this says add 2x, I can actually put those together and make 6x minus 3. Okay. All right, and so anytime we collect those like terms, and then actually we can, both of those have 3 as a factor, so I can actually put 3 out here and rewrite this as 2x minus 1. Because I got to multiply by all the parts. It still comes out the same thing. But our big thing here is the like terms, and that we can put them together. Or take them apart if they're subtraction. All right. That is all for today. Thanks for watching along.